Hi everyone, my name is Parth and I'm back with another video tutorial. So this video tutorial will talk about solid principles in .NET. So let's begin. So the agenda would be, we would start by looking what do we mean by these solid principles. So solid principles, basically these are 5 principles. So we'll see each one of them one by one. We will start with single responsibility principle. Then we'll go to open close principle, followed by Liskov substitution principle, then interface segregation principle, and finally the dependency inversion principle. So what does this solid principles term mean? Solid principles are nothing but they are some design principles which were created on the advent of .NET framework to help solve some of the architectural problems while developing and designing the .NET applications. So these design principles basically help us to move the code very in a very efficient manner between our different classes, you can say, or different components, which makes coding very easier to maintain later on, basically in terms of making it more maintainable, more understandable, and more flexible for everyone who is working on that particular application. As mentioned, solid principles is a group of 5 principles, where S stands for single responsibility principle, O stands for open close principle, L stands for Leskov's substitution principle, I stands for interface segregation principle, and D stands for dependency inversion principle. So let's start with the first, single responsibility principle. So this principle states that when you are creating an application, in that particular application, one class should have only one responsibility. It should not be handling multiple jobs at the same time. So it should have only one reason to change. Like in order to basically have a class created, you should keep in mind or take care that you should have that class change the code only for one reason, or you can say should have only one responsibility. That is what the single responsibility principle states. Let's understand this with an example. So here you can see we have a class employee, and inside this class we have two methods. One is calculating the salary, or you can say pay, of the employee, and one is save the data of the employees. So you see that there's an issue in this code. We have a save logic and we have a business logic to calculate the salary. So this class is basically having more than one responsibility. One is to calculate the pay and the other is to save the employee details, right? So this is an issue in this class employee. Now let's see what is the solution for this. So the solution is very simple. You just have to separate these two methods into two different classes. So you have to just create two different classes. So let it be that the calculate pay method still remain in the employee class. For saving the employee details, you can create another class. And you can see here, employee repository. So now this class follows the single responsibility principle. Since both of these classes have only one responsibility or only one action to perform. Like employee class have the responsibility to calculate salary, and employee repository class has the responsibility to save the employee data. Next comes the open close principle. So open close principle states that a class should be open for extension, but should be closed for modifications, which means that when you are having a class, which is your base code, let's say, whenever you are trying to implement some new functionality, you should not modify the existing class code. Rather, you should inherit that class into your different classes, the new classes which you have created, and then override the functionality of that particular base class. Let's see an example. So you can see we have a class here, payment manager, and it's basically doing some kind of logic based on the payment type. So you can see here the first payment type is cash. So you see that there's an issue in this current code. Let's say tomorrow I have to add one more payment type. Let's say credit card, or let's say debit card. So I will have to modify this current class, which becomes a problem. So the solution for it is we can just create one virtual method in our payment class. You can say here with the name pay, and we can just inherit that in our multiple child classes. You can say one, you can see on the left we have cash payment, on the right we have credit card payment. So you see it's very simple to just override that method pay from the base class payment into our multiple child classes. Now tomorrow, let's say I want to add one more payment methods, let's say debit card payment. So I will have to not change the code of the my parent class, which is the payment class. I will just inherit that class into my child class, which is debit card payment, and it will serve the purpose for me. So here you see we are opening the class for implementation, means for inheritance, but it's closed for the updation of the code. Third comes the Liskov substitution principle. So here it states that a child class should be able to extend the base class or the parent class functionality without changing any behavior. In short, it means that in place of where you are using a parent class, you can use a child class without affecting the behavior. So let's see one example. You see we have a class here, employee. And now you see we have two child classes, casual employee and contractual employee. So you see an issue in the current code. Now you see in the contractual employee class, we have a get project details method. Now in order for this class to serve the purpose of the base class by calling the get project details method, it will not be able to do so, because in the get project details, which is in the contractual employee class, it's just printing a statement which says contractual employee project details. It's not, there is no provision for us to use this contractual employee child class instead of our base class. So in order to solve this, we have a solution. Let's see that. So now you can see that in our contractual employee class, we are calling the get project details method of our base class, which is the employee class, by using the base keyword, right? Now this will serve us a purpose where we can basically perform the same operation of calling the get project details from inside our child class, which is the contractual employee class, instead of directly going to the creating the object of employee class and then calling that particular method. So this solves a purpose, and this basically is in accordance with the Liskov's substitution principle. Next is the interface segregation principle. So this principle states that the clients or the customers should not be forced to depend upon the interfaces or to inherit those interfaces or functionalities which they don't want. So basically, it means in the coding language that each code object should only implement what it needs and not be required to implement anything else which it does not need or want. So you can see we have an example here where we have an interface iEmployee, which has two methods, get project details and get employee details. Now we have two classes, casual employee and contractual employee. Both are basically implementing the interface iEmployee. Now let's say you can see on the right side, the contractual employee does not want to implement the get employee details method of this iEmployee interface. So necessarily he again has to write some particular code, because in interface, what all methods we have, we just have to implement those when we are inheriting an interface in our class. Now this becomes a, you can say nuisance, or the client will become irritated, since the client does not want this method to be used in his class while he is inheriting that interface I employ. The solution is very simple. We'll just separate both the methods into two different interfaces by creating two different interfaces. So I employee interface has now one method, get employee details, and the second interface I project has the second method, which is the get project details. So now you can see the casual employee, as earlier, wants to implement both the methods. So he's inheriting both the interfaces, I employee and I project. Whereas on the right hand side, you can see the contractual employee client just wants to implement the get project details. So he is just implementing the I project interface by inheriting it. Last one is the dependency inversion principle. So it states that there should not be any tight coupling between the different classes and components. Basically, the high level modules should not depend on the low level modules. There should be a layer of abstraction between the two. So you can see on the right side in the image, the traditional thing is like whenever you want to inherit something, let's say some class, you just call that every time. So it will create the basically it will be inherited multiple times. So you basically have the direct access to the class. There is no layer in between. But on the dependency, if you see dependency injected on inversion principle, you see here we have a dependency injector here, which basically acts as a injector, which creates the object of the main class which we want and then injects it into the different components, as you can see in the image. So let's understand this with an example. Let's say we have a class email and we have a class notification. Now there's an issue in this code. Let's say I want to send not only the email tomorrow, I also want to have the functionality of send SMS. Now this will cause an issue. Now we again have to modify the existing code, correct? So this is an issue in the current code. Now the solution is very simple. We'll create one iMessenger interface where we'll have a send message method, and we'll have two classes, email and SMS, which will inherit those interfaces, and both will basically implement that send message method of the interface. So like one will send the message through email and one will send the message through SMS. And then in the notification class, basically we can inject that interface as a dependency and send the, you can say, the message through email or SMS as we want. So there are three ways of injecting the dependency into this class notification. First is the constructor injection. So you can see in this class notification, we are passing the reference of the iMessenger interface. You can see in the constructor public notification in the bracket iMessenger space p messenger. So this is we are injecting the dependency in the constructor of this class. And then we are calling that in the do notify method to send the message. Second type is through property injection. So here you see we have created a public property, right? And we are setting the value in that property, and then we are using that to basically send the message in our do notify method. The final one is using method injection. So here you see that we have a method do notify. We are passing that interface reference as a parameter, and we are calling the send message method inside our do notify method. That's it from my end. So I hope you might have got a basic understanding of solid principles. So I will see you in some other video very soon. Thank you.